Hello and welcome to Unit 18, Computational Thinking. What is computational thinking? Computational thinking is to think of computers when you have a problem to solve, when you have a task to do. You need to think of using computers to help you to solve it. And ideally is that you can let the computer solve it automatically without you doing much. Okay, that's computational thinking, the basic principle behind it. How can you achieve it? Now that requires logical thinking. That means you're using readily available information to solve problems without making assumptions or taking shortcuts. A good example of that is the Sudoku numbers game. Logical thinking is required in many fields, not only in computational thinking, but it is essential for computational thinking. Apart from logical thinking, algorithmic thinking is also required. This enables automation, automatic solving problems by the computer, because the computer will be given the predefined set of instructions, which is obviously set in the program. Then, computational thinking requires optimal thinking, which means you need to reflect on your solution to make it even more efficient. This is again not exclusive to computational thinking. Above all, you need to think abstractively. Abstraction is the foundation of computational thinking, because a computer can only understand numbers, specifically only understanding binary numbers, zeros and ones. So everything you want the computer to do has to be converted into numbers. Okay? Therefore, abstraction is one. Algorithmic thinking is two. And then on top of that, on every part of them, you need to have logical thinking and optimal thinking. So those are the basic features involved in computational thinking. If you want to apply computational thinking, you need to follow these 6 steps. Step 1, break down the problem into smaller chunks, smaller tasks, so that it becomes more manageable, both in terms of working out the input, the processing, and output. Step 2, you need to use visualization tools to represent the problem. The problem must be represented, abstracted, so that you can design a solution for it. It has to be represented, basically in numbers and charts. You need to design a solution using mathematical methods. Mathematical methods could be arithmetic calculations, could be logic comparisons. Then you create a solution on a computer platform, and then you test it, see if it works, and then you refine it to apply the optimal thinking. Those 6 steps are essential for computational thinking applied in real life. For example, you want to design tests for students. Well, we need to think about it, and to design a test, you need to break it down to smaller tasks. That's step 1. Okay, now look at it. A test has questions and descriptions of the question, and chart diagrams and illustrations to help, and maybe options to choose, and a space to collect answers. And then each question needs to be marked, and the marks need to be recorded. The total marks need to be calculated and recorded, the total marks for the whole paper, for the whole test. Okay, traditionally, how is that achieved? Traditionally, it's a paper-based test. So everything is printed on paper. And the teacher will mark the paper and write the marks on the paper, and then calculate the total marks, and then record the totals of each student into a grade book. Computational thinking. It was printed on paper. What can we? Or is it possible to display everything on computer screen? Okay. Teacher marks the paper and write on the paper. Or can the computer mark each question and then display the answers on computer, on the screen? And can the computer calculate the total marks, because the teacher did the marking, the calculation manually? And then finally, can the computer send the totals into a place to keep them together? That's the recording into the gradebook. The computational thinking. So I've got a problem, I need to think, can I use the computer to solve it? Then you need to do this. Visualization. The answer, obviously, the answer to them is here. Yes, you can display them on screen. Yes, the computers can mark some of the questions, but not all the questions. Some questions, if you have written on the screen in free text form, it will be hard. How do we visually represent the problem, we could use storyboard to represent the layout of the questions. We could use formulas and algorithms to work out how the questions are marked, how the calculations are done, and we can also use code to send the total marks to a different program or different part of the same program. So that's the visualization. Okay, you can use storyboard there. You can use algorithms over there for representing algorithms. You can use English descriptions, or you can use flowcharts, or you can use pseudocode, and so on. Okay, so that's the design stage. Here is what I've created on computer and in Microsoft Excel. You can see I've laid out the questions and options, and I've left a space for collecting answer. The student would type in A because it's option A, and this formula is for working out the answer, the mark for that question. If it's right, you give 2 marks. If it's wrong, you don't give. The one below is if you get it wrong, you get 1 penalty point, -1. This is good to prevent guessing. That's method number 1. To apply optimal thinking, well, I could have 1 method, 2 methods, 3 methods, and even more. Okay, I'm not showing all of them. And you compare, is 1 better than 2 or 2 better than 1? Okay, I think 2 is better than 1 because the answers will be typed in next to the option letters, which cause minimum disruption and confusion. And this one, the eye movement across the screen will sometimes cause confusion, cause errors. Okay, so in the final version, I will code this part and as the final solution, as the optimal solution. Okay, and that is exactly what I've done. Then I've done the coding using formulas to check the answers. I'll give, if any of the wrong answers is collected, get 1 penalty point, and if the correct answer is chosen, you get 2 points. And here on the right hand side is the testing. You can see correct answer 2 marks, correct answer 2 marks, and the total marks is calculated there. And the computer did all the marking. All the teacher did was setting up the tests. Okay, so I have applied computational thinking to design a test to use computer to automatically mark the tests and collect the answers. In this unit, you are going to create a computerized test like this one.